Right, welcome back everyone. Today we're going to cover 5.8 in our current book. In the future this might be a different section, but the topic or concept is polynomial equations. And so what is the difference between what we've been doing, which is factoring, and polynomial equations? So same problem, right? But this one would say factor completely. Okay, and this one would say solve. Well, the reason why, or what makes them different, is your goal. That's an ugly L. Then your goal is different. Okay, here, this is an expression. So we're factoring it. We're going to say, oh, there's no GCF here. This is a three-term polynomial that I can use hippobutts to factor. So the last number is what times what. That's going to be a positive 8 and a positive 3. And my answer is these factors. This is factored completely. This is a different question than this one. This is now an equation. Okay, so the difference is there is an equal sign. But it's an equation, but the thing that makes it an equation is this equal sign. And when we have an equal sign, this is asking us to do something different. This is asking us to find the values for x that would make this statement true. The way we're going to do that is we're going to go through the following steps. First thing we're going to do is we're going to make sure that it's in standard form. Okay, the standard form right here is ax squared plus bx plus c equals 0. Or in other words, I just always say I'm going to get all the crap on one side and make sure that it's equal to 0. When it's equal to 0, and only when it's equal to 0, we can factor it completely. Well, factor completely isn't going to be any different than this step. So I'm going to again say there's no GCF. I'm going to count the terms. There's 1, 2, 3 terms. I'm going to determine that my method is hippobutts, and I'm going to factor completely. But this isn't the answer. This is just part of finding what I would be plugging in for x to make this statement true. Well, we can use the zero property rule that says basically if I can make either one of these factors 0, remember that 0 times anything is 0 and anything times 0 is 0. All right, so I'm going to use this fact here and say, well, if I set this factor equal to 0 and I set this factor equal to 0, if either one of these factors are 0, then the whole thing would be 0. So if I set each factor containing a variable equal to 0, and then I solve the resulting equation. So I'm going to subtract 8 and subtract 3. So this says that x is equal to negative 8 and x is equal to negative 3. Now let's see if we can make sense of this. If x were negative 8, if I substituted into these factors, right? If x was negative 8, well, negative 8 plus 8 is 0, and 0 times a negative 5 is 0. So we can see that this zero property rule works. If I can make either one of these factors 0, then this whole thing would be 0. Let's substitute a negative 3 into these factors right here. And you can see again, this is 0. So I'm going to get 5 times a 0 is 0. So this is why I'm setting each factor that contains a variable equal to 0. As we go through here, I'm going to point out different critical parts of solving this. Checking each solution, we didn't actually check the solution. This was to show you the zero property rule. Okay, if we wanted to check this, I wouldn't put it into the factored form. I'd plug it into the original equation. So a check would look like this. I would say, well, if I plug in negative 8, square it, add 11, times that by negative 8, and add 24, is that equal to 0? Is this original statement true? Well, this is going to be a 64 minus an 88 plus 24 is equal to 0. Well, 64 plus 24 is 88 minus 88. 0 is equal to 0. This is a true statement. The original statement is true when my variable is negative 8. Okay, that is the check. step 5. We could do the same thing with -3. I'm not going to spend time in this video checking, but you should always check every solution. Okay, something else that I want to point out here is notice that we got 2 solutions here. We got that x is 2 things. And the reason why we get this is because the degree of this polynomial is 2. So whatever the degree of the polynomial is how many solutions you will get. So if this was x cubed, I would get 3 solutions. If it was x to the 4th, I would get 4 solutions, and so on. So we should know how many answers we're going to get by the degree of the polynomial when it's in standard form equal to 0. Okay, so again, difference between factoring completely is that I'm going to end with factors here, because this is an expression, and solving a polynomial equation is I'm going to get the values for x that I could substitute into the original equation. That would make it true. Okay, so hopefully that is helpful. So let's talk about a couple of other parts of this. So what would be then the difference between x plus 3 times x minus 2 is equal to 0 versus x plus 3 times x minus 2 and saying, oh, this is equal to a -4 instead. Okay. Sorry about that. Well, since these factors are, this polynomial right here is already factored and it's equal to 0, then I can literally say, oh my gosh, I could just set each one of these factors equal to 0 and solve and get that x is -3 and x is a +2. So those are my 2 answers. Because, really important here, because these are factored, but they're equal to 0. That's why I could just solve it, because basically this was given to me at step 2. It was already solved. I want to point out here that what you're actually saying is that if I substituted, when I'm setting each factor to 0, okay, what I'm saying here is if I substituted -3 into this factor, then this factor would be 0. And if I substituted 2 into this factor, then this factor would be 0. And you can see that those are the answers. Okay, well, this one here, how are these different? Well, this one here is already in factored form, so can't I just say that x is equal to a -3 and a 2 here as well? The answer is no, because this is not equal to 0. I didn't meet the first qualification here. It's not in standard form equal to 0. Now, I could multiply this back out to make it in standard form, but that would be silly. It's already equal to 0 and factored, so I want to work smarter, not harder. But here, I can't just say, oh, 3 and 2, -3 and 2 would make this 0. I have to do exactly what I just said. Multiply this out. Okay, get x squared plus a 3x minus a 2 x minus 6, and that's going to be equal to -4. So we'll get x squared plus x minus 6 is equal to -4. Now I need to get this equal to 0, so I'm going to add 4 to both sides. So I get x squared plus x minus 2 is equal to 0. Now that it's in standard form equal to 0, again, critical here, now I can factor this, and you'll see here that the factors are different. This is a 3-term polynomial that has a coefficient of 1. So this is going to be factored using hippobutts. And it's going to be a +2 and a -1. So when I set each factor that contains a variable equal to 0, then I get that x is -2 and x is a +1, right? Or just 1. You can see that that's different than a -3 and a 2. My answers here are different because this was not equal to 0 to begin with. So if you have factors equal to 0, I can just say, oh, I could substitute -3 and 2 and be done. But here you have to put it in standard form, set it equal to 0, and then go through the process. Okay. So again, if you don't want to do all of these steps, because maybe it's obvious to you, oh my gosh, if I plugged in -2 right here for x, then this factor would be 0. And if I plugged in 1 right here for x, then this factor would be 0. You can skip down here to this step. But just want to make sure we understand the importance of making sure that it's equal to 0 before we set factors, each factor equal to 0. Okay, next concept. Well, what if it's not in standard form? Well, we just did one that wasn't in standard form. It was factored or had some multiplication that I needed to do. We could also have something like this. Okay, so several occasions where they're not in standard form. All right, well, if I want to put this in standard form, I have to multiply this out. Get a 5x squared plus a 2x is equal to 3. Subtract the 3 over, because remember, I want to get all my junk equal to 0. All right, so now I'm going to look and say the factor completely. I'm going to say, is there a GCF? 5, 2, and 3 do not have GCF. There's no x's all along here. So now I'm going to count the number of terms. I've got 1, 2, 3 terms. That tells me that I have a trinomial with a coefficient greater than 1. I'm going to use synthetic factoring. So my first step here is going to be 5 times a -3, which is going to give me a -15. Factors of -15 that are going to sum to a +2 are the 5 and the -3 that I just multiplied together. These multiply to the -15 and they sum to a +2. So I need them to sum to the middle one. I'm going to write these factors over a, which is 5, and then reduce the fractions. Again, this is a positive here and I need that sign, so this is going to be a +1 over 1. I'm going to write it as a fraction, and a -3 over 5. Each one of these fractions represent a factor. In this case, it's going to be x plus 1 and a 5x minus 3. Okay, so I rewrote these fractions, these reduced fractions, as factors. Now, remember that this is all equal to 0, so I'm going to set each factor equal to 0. So x is going to be equal to a -1, and I'm going to set this 5x minus 3 equal to 0. Add the 3. And I get that 5x is equal to 3, divide by 5, and x is 3/5. That's hard to tell. See, 3/5 here. Okay, so my two values that I'm going to get, which we know we're going to get 2 because this polynomial has a degree of 2. Okay, we know we're going to get 2. It's going to be x is equal to this -1 right here and the 3/5. So those are my two answers. Again, we should always check those, but I want to show you something. You know how when I taught you synthetic factoring, when we learned this method here, synthetic factoring, I said this is a shortcut. So when we're using synthetic factoring, we can stop at factor completely. Okay, we can stop right here if we're using synthetic. And we can change, this delta sign means change. We can change the signs. Let me show you what I mean. Notice that this is the same as this, same as these factors right here, but with opposite signs. So I get a +1 here, I'm just going to change it to a -1. I get a -3/5 here, I'm going to change it to 3/5, because you don't have to do this step. You don't have to put it into factored form and then set each factor to 0. You already have the answers right here. So this is that shortcut that I was talking about. Okay, if you're using synthetic factoring, this doesn't work with any other method, just with synthetic factoring. Okay, so let's keep going here. Let's say that I have the equation 25x squared minus a 40x plus 16 is equal to 0. All right, so lucky me, this is already equal to 0, so step 1 is complete. Step 2, I need to factor completely. This is a 3-term polynomial with no GCF, so I'm going to use synthetic factoring again. I'm going to get 25 times 16. This is step 1. A times C is equal to 400. Again, whenever you get like these huge numbers, you should stop and you should think, maybe this is a perfect square trinomial. So let's test that theory. Perfect square trinomial. Well, 25x squared is a perfect square. The root is 5x. 16 is a perfect square. The root is 4. 5x times 4 is 20x. This is double. So this is a perfect square trinomial. Remember that means that I can just dump the factors of 5x in here and the factors of 4. Whatever sign this is going to be the same, and this is going to be squared. Okay, so this is what it looks like in factored form, but right now it's equal to 0. What this means is that I have 2 of these factors. So if I set this factor equal to 0, and I set this factor equal to 0, they're the same equation, right? So I get that 5x is equal to 4 divided by 5. I think I'm off the screen here. So let's say x is 4/5. And if I solve this equation right here, I'm going to get exactly the same thing because they're the same factors. Okay, so I actually only get one answer here. So this is an exception that happens here. It's actually not one answer. You can see that it's the same answer twice. So this is called a repeated solution. Okay, it's repeated. Because we just said we're going to have as many answers as the degree of this polynomial. This polynomial has a degree of 2, so I should have 2 answers here, but then I only get this one answer. Well, actually, I get 2. It just repeats itself, and since it's the same answer twice, okay, then I only need to write it once. So don't let that fool you into saying, oh my gosh, I'm missing one of the solutions here. Just want to point out, if we kept doing synthetic factoring, I would have gotten a -20 and a -20. This would be over 25, and you can see that this reduces to a -4/5, which with synthetic factoring, we said, oh, you can stop after factoring this step 4 and change the sign. So you can see here that you would have gotten 4/5, but both of these would be 4/5, so you'd get that twice. Again, that is called a repeated factor. This happens when you have a perfect square trinomial. Okay, let's do one where we start out with fractions and figure out what we do from there. So if I had x squared over 4 minus a 5/2 x plus 6, and that's equal to 0. Lucky for me, this is already equal to 0, so all I need to do here is get rid of the fractions. Okay, so to put this in standard form, I want to clear the fractions. So right now we're going to clear the fractions. This is part of step 1, getting it into standard form. Well, the GCF here, or sorry, the least common denominator is 4. This already has a denominator of 4. I want to make this one have a denominator of 4. And this have a denominator of 4. And when they all have a denominator of 4, I can wipe out the denominators and only have what's left in the numerator. So I will have x squared minus a 10x plus 24 is equal to 0. Okay, so this is a 3-term polynomial with coefficient of 1 with no GCF, so I'm using Hippobuts. The factors of 24 are going to be -6 and a -4. Those multiplied to the 24 and sum to the 10. And what I would have to plug in to this factor right here would be 6, and to this factor right here would be 4. So those are my 2 answers, which I should get to here. Okay, a couple more problems. Something weird that can happen is if you have a, say like this isn't in standard form, but say it's cubed now. I've got it cubed, so this should be interesting. So let's put this in standard form. Again, all that means is I'm going to put everything equal to 0. I could do this in two ways. I could move both of these terms to this side and then factor out the negative. Okay, or I could move the t cubed to this side to keep it in standard form and to keep the leading coefficient positive. So I'm going to move the t cubed to this side. So I get that 0 is equal to a t cubed minus a 15t squared plus a 54t. Okay, so whether the 0's on the right side or the left side doesn't matter. So now I'm going to factor completely. Well, my steps of factoring completely is factoring out a GCF. Here, if I see that I have a t in common. Okay, so this is all equal to 0. What I'm going to point out here is it's really important that we notice that we're going to set each factor that contains a variable equal to 0. This right here, this t, it's a factor. Okay, and the degree of this polynomial is 3, so I should get 3 answers here. All right, so I've factored out the GCF. I'm going to count the terms. It's a 3-term polynomial. And this is going to be another hippobutts. So I'm going to get t's here and 54 factors of 54. We're going to get a 9 and a 6. So it's going to be a minus 9 and a minus 6. They multiply to a positive 54 and sum to a negative 15. So remember that all 3 of these factors are equal to 0. This is a factor, so I need to put t equal to 0, t minus 9 equal to 0, and t minus 6 equal to 0. When I add the 9 to both sides here, I get that t is equal to 9. When I add the 6 to both sides, I get that t is equal to 6. But t is also equal to 0. 0 can be an answer. If I plug 0 into this original statement, oops, the negative's not inside the t, sorry. Okay, well, this is 0, this is 0, and this is 0. So it's true that 0 equals 0. So 0 is one of the solutions. So these are the 3 solutions. I get that t is equal to 0, it's equal to 9, and it's equal to 6. And I got 3 solutions, which I was expecting because the degree of this polynomial was 3. Okay, so it's really important to note that if you have a factor that contains a variable, you need to set every variable equal to 0. But what if I don't have a variable? Say that instead I have a let's do 2r squared plus a 6r is going to be equal to 20. Okay, so this is not set equal to 0, so I'm going to subtract the 20 from both sides to do that. So now I have a 2r squared plus a 6r minus 20 is equal to 0. Well, now I'm going to go through my steps here and say, is there a GCF? Well, there's a 2 in every one of these factors, so I can factor out a 2. There's not an r in all of them, though. So I can factor out the 2, so I'm going to get r squared plus a 3r minus 10 is going to be equal to 0. To continue factoring completely here, I'm going to say this is a 3-term polynomial with a coefficient of 1, so this is going to be a hippobutts. Factors are 5 and 2, and the signs are going to be a positive 5 and a negative 2. Those multiply to the negative 10 and sum to the positive 3. Well, what happens to this factor right here? It is a factor. It is a factor. But we don't care about factors that don't contain a variable. And the reason why is because if I took this factor and I set it equal to 0, so I say that 2 is equal to 0, r plus 5 is equal to 0, and r minus 2 is equal to 0. Well, we all know this. 2 is never going to be equal to 0. So this factor ends up getting thrown out because a constant will never equal 0. So when we factor out GCFs, our constants, a constant GCF doesn't matter, but our variables do. Okay, so, and it makes sense I would end up throwing this out because this has a degree of 2 here, so I should only get 2 solutions. This third solution here isn't a solution, it's just a constant. And the other reason why is I could take and divide both sides of this equation by 2 and still just end up with this r plus 5, r minus 2 is equal to 0. Okay, so I'm going to subtract 5 here and add the 2 here. So we get that r is equal to a negative 5 and a positive 2. Excuse me. Again, we get two solutions because the degree is 2, and we can throw out any GCF that is a constant. Okay, so focus here on factors containing variables. Last problem I want to do is an application problem. Most likely you will see something like this on the final exam, so take note of this. So I'm going to write down the equation that goes with this story, not the story itself, and because the equation is all that matters. Okay, so what is the story here? The story is that, suppose that a movie is being filmed in New York City. An action shot requires an object to be thrown upward at initial velocity of 80 feet per second. Okay, this is my initial velocity of 80 feet per second off the top of Madison Square Plaza, which is a height of 576 feet. The height, h of t, in feet of the object after t seconds, so t stands for the time, is given by this function. So again, it's a lot of words to say, whoa, this is just the function. So the h of t stands for the height, okay, of the object, and t itself stands for time. Okay, determine how long before the object strikes the ground. When they say hits the ground, this word ground, well, the ground is at 0 feet. So we are asking how long will it take? Okay, so determine how long before the object strikes the ground. How long will it take in seconds, okay, time in seconds, for the height of this object to be 0? Because right now it's 576, and then you go and chuck it, right? So let's draw this little picture of what's happening. You've got this building, and it's 576 feet tall. Then you go and chuck this object upward, and it's going to go like this. So the question is, when's it going to hit the ground? Well, that means when is the height equal to 0? This is literally all this is asking, is to set this equation equal to 0. Okay. Let me rewrite this down below. So when it says hit the ground, that just means substitute this h of t for 0. Okay, so when I do that, my first step is going to be to factor out the GCF. Because I have a leading coefficient of a negative, I have to factor out the negative 16. Well, if that is the common factor. 80, it goes into 80, and it goes into 576. 36 times. So there is a common factor there. So I'll get 2t when I divide, t squared when I divide negative 16, t squared by negative 16. When I divide 80t by negative 16, I get a minus 5t. And when I divide 576 by 16, I get a minus 36. Okay, and remember, this is all equal to 0. Well, what do we do with this 16? It is a factor, but it's not a variable factor, so I can just ignore it because negative 16 will never be equal to 0. So now I'm going to set, I'm going to factor t squared minus 5t minus 36 completely. This is another hippobutts, so I'm going to get a 9 and a 4. It's going to be a minus 9 and a positive 4. Those multiply to the negative 36 and sum to the negative 5. So if I set each factor now equal to 0, t minus 9 and counting. Gonna add 9 to both sides here and subtract 4. Then I get these two answers. T is equal to 9 and it's equal to negative 4. But let's interpret t. What is t again? T stands for time in seconds. Okay, so I have a degree of 2 here, so I expected to get 2 answers. So this means at 9 seconds and at negative 4 seconds, this object will be on the ground. At 9 and negative 4 seconds, this object will be on the ground. Anybody having a problem with this? Well, first of all, we can't ever move backwards in time. So if you're talking about a real life situation, you can get rid of this negative 4. So the answer to this question is it will take 9 seconds for the object to hit the ground. Okay, 9 seconds for the object to hit the ground. That's pretty interesting. So why is this important? Well, if you were filming a movie and you were trying to get an action shot or something, you would actually need to know this information to know when to film or what to film or how long you had. Okay, so why the heck did we get this negative 4 if we can't go backwards in time? I'm just confused about this. Well, what this is if this parabola had continued, okay, so if this was a full parabola, this time, if we could go backwards in time, would be the negative 4 seconds, which is where it started. So if it had started right here at 0 and then been thrown, we would be at 0 here and be at 0 here. But because we're in real life, time can't go past here, so we can't have negative time. But that's why we get that negative 4. Okay, so this is the end of 5.8. Hope that all made sense, and we will see you in class.